ever wondered how data is transferred between different routing protocols? Welcome to the fascinating world of network redistribution, a fundamental concept that's crucial in the realm of networking. Redistribution, in essence, is the process that allows route information to be shared between different routing protocols. Imagine a busy city with numerous roads, highways, and intersections. Routing protocols are like the various routes in this city. Now, what if these routes could exchange information about the fastest, most efficient paths? That's precisely what redistribution accomplishes in a network. It's like a universal translator, enabling different protocols to understand and share route data. This sharing of information is critical in ensuring seamless communication and data transfer across diverse network protocols. Without redistribution, our networks might resemble that chaotic city, with data packets lost in a maze of disjointed routes. Now that you have a basic understanding of redistribution, let's delve deeper into its workings. So how does redistribution actually work? Well, let's break it down step by step. Redistribution is a process that allows a router running multiple routing protocols to share information between them. Think of it as a translator that helps different languages, or in this case, different protocols, to understand each other. First, the router identifies the routing protocols that it is running. This could be any combination of protocols such as Open Shortest Path, FIRST, OSPF, Enhanced Interior Gateway, Routing Protocol, eGRP, or Border Gateway Protocol, BGP, among others. Once the router knows which protocols are in play, it then starts the process of redistribution. The router translates the routes from one protocol into a language that the other protocol can understand, effectively sharing the routing information between the two. This is where the metric system comes into play. Each routing protocol uses a different metric to determine the best path for data to travel. For example, OSPF uses cost as its metric, while eGRP uses a combination of bandwidth and delay. When redistributing, the router has to translate these metrics from one protocol to the other. This can be a tricky process as the metrics are not directly comparable. The router uses a metric for the new protocol that is equivalent to the metric of the original protocol. For instance, if a route in OSPF has a cost of 20, the router might assign a metric of 200 to that route when redistributing to eGRP. This is because eGRP's metrics are generally higher than OSPF's. Finally, the router updates its routing tables with the redistributed routes. These new routes are then propagated to other routers running the same protocols, allowing them to update their own routing tables. And there you have it. That's the process of redistribution in a nutshell. It's a fundamental part of network routing, allowing different protocols to coexist and share information seamlessly. You have now learned how redistribution works. Next, we will discuss configuring and verifying redistribution scenarios. Ready to learn how to configure redistribution between routing protocols? Let's dive right in. First things first. The core of our configuration process lies in setting up the router to redistribute routing information. To do this, we'll need to navigate to the router configuration mode. Here, we'll use the router command followed by the name of the protocol we're working with. Next, we'll employ the redistribute command. This command allows the router to share information between different routing protocols. For example, if we're redistributing routes from OSPF into eGRP, we'll issue the command redistribute OSPF followed by the process ID. It's important to note that the process ID is unique to OSPF. For other protocols, we'd use the autonomous system number instead. Now, here's where things get a bit tricky. When redistributing routes, we need to set the correct metric values. This is crucial because each protocol uses a different metric system. For instance, in our OSPF to eGRP redistribution, OSPF uses cost as its metric, while eGRP uses a composite metric. So, when we redistribute from OSPF, we need to assign a metric that eGRP understands. We do this by appending the metric keyword followed by the values that define the egroup metric. As we're configuring redistribution, it's important to be aware of potential pitfalls. One such pitfall is routing loops. These can occur when two routing protocols keep redistributing routes to each other, creating a loop. To prevent this, we can use route filtering, which allows us to control which routes are redistributed. Another potential issue is suboptimal routing. This happens when the path that data takes through the network isn't the most efficient. The solution? Again, careful planning and configuration. Make sure to thoroughly understand your network topology and the behavior of each routing protocol. Lastly, let's discuss the default behavior of redistribution. By default, a router will only redistribute routes that it has learned via the same routing protocol. However, we can alter this behavior by using the redistribute connected command. This command tells the router to also redistribute routes for directly connected networks. In conclusion, configuring redistribution involves a careful mix of commands, metrics, and an understanding of potential issues. It's a process that requires attention to detail and a thorough understanding of the workings of different routing protocols. Remember, the goal here is to ensure seamless communication between different parts of our network, even if they're using different routing protocols. And with careful planning and configuration, we can achieve just that. We've now configured redistribution. Let's move on to verification. Now, how do we ensure that our configuration was successful? Well, it's all about verification. Verification is the process of ensuring that the redistribution between routing protocols has been configured correctly and is functioning as expected. The first step in the verification process is checking the routing table. The routing table is essentially the map that your router uses to determine where to send packets. It's the ultimate source of truth when it comes to understanding how your network is configured. If redistribution is working correctly, you should be able to see routes from one protocol appearing in the routing table of the other. But what if you don't see the routes you expected? This is where debugging comes into play. Debugging commands allow you to peek under the hood and see what's happening in real time. For example, you might use a command like debug IP routing to see route updates as they happen. These real-time updates can be incredibly helpful in pinpointing any issues. Now, a word of caution here. Debugging commands can be resource-intensive and may slow down your network if used excessively. So, always remember to turn off debugging when you're done. And then comes troubleshooting. This is where your detective skills come into play. You might need to double-check your configurations, ensure that your routing protocols are correctly linked, or even check for software bugs. Remember, the devil is in the details, so don't overlook anything. One more tip. Always keep the end goal in mind. Your aim is to have a smoothly functioning network where packets can travel freely from one protocol to another. If you're not achieving that, something needs to be adjusted. In the world of network engineering, verification is not just a one-time process. It's an ongoing task that requires constant vigilance and a keen eye for detail. It's about ensuring that your network is always performing at its best. With that, we have verified the redistribution process. Let's summarize what we have learned. So, what have we learned today? We've journeyed through the intricate realm of redistribution between different routing protocols, a subject of immense importance for all network engineers, and indeed anyone with an interest in the functioning of our digital world. We began by introducing redistribution. We discovered that this is the process by which routing information is exchanged between different routing protocols. This is a critical function in network systems as it ensures seamless communication between networks using different protocols. Next, we delved into the nuts and bolts of the redistribution process. We understood that this involves two key steps. First, the conversion of routing information from one protocol into a common format. And second, the conversion of this common format back into the format of the receiving protocol. We then rolled up our sleeves and got our hands dirty with the configuration of redistribution. We saw how this involves a series of steps, starting with the identification of the routing protocols involved, moving on to the configuration of the redistribution command on the relevant routers, and finally, the setting of metrics if necessary. Our journey didn't end there though. We then moved on to the verification of redistribution, a crucial step in any networking process. This ensures that the redistribution has been correctly configured and is functioning as expected. We saw how this can be done using various show commands on the router. But why is all this important? Understanding the concept of redistribution, how to configure it and verify it, is crucial for network engineers. It enables them to ensure the smooth functioning of the networks they manage, to troubleshoot any issues that may arise, and to keep the digital world running smoothly. And with that, we have demystified the concept of redistribution between routing protocols. Keep exploring and remember, knowledge is power in the world of networking.